Okay, so I just want to finish up the notes from class. This is example 5, which is find the volume V obtained by revolving the region between y equals x squared plus 4 and y equals 2 about the x-axis for x between 1 and 3. So first, let's draw a picture of this. Okay, so here's how our picture should look. This is, of course, y equals 2, and this is our y equals x squared plus 4 function curve. And if we took, this is rotating about the x, so you don't have to draw the complete solid, but imagine taking a slice and you're rotating that slice around the x-axis. And so what it's going to look like is, so if you look at, and I'm going to do this with I'll do it in black, I guess. So we're taking that, right, which is actually when we rotate it, so that's what we used to rotate. Now again, when we rotate, we're going to make concentric circles, or that's what the washer method. So just imagine rotating that around, and it can be as symmetric as you want. So that's how our cross section will look. So then remember, so our volume is going to be the integral from 1 to 3 of pi of f of x squared minus g of x squared dx. Okay, keeping in mind, f of x is the larger function from the definition. And so here, this will represent our f of x function, and this would be our g of x function at y equals 2, if we want to look at it like that. And so the volume is just going to equal the integral from 1 to 3. But here's the thing, you need to be clear, and that's why we had to draw this picture. So you do need a picture here. Unlike the disk method where it's just one function, you do need a picture here because you don't know which function is on top and which one is on bottom, right? The bottom. That's why instead of calling it the functions f of x and g of x, I sometimes will just call it y, because you will need to determine which one is the top. But it could be g of x in the section. I could call something g of x by accident. I'll try to keep it in terms of y, but in case I forget, if g of x was on top, now it would be that top function would come first, right? So it's arbitrary, and that's why I try to keep them in terms of y, and I'll try to remember to keep them in terms of y. I don't know how your homework has it, so just know in that the definition f of x is always representing the top function, even if it's called something else. And so here we see our top function is going to be x squared plus 4 minus g of x is just 2, right? And that's squared dx. All right. So go ahead and take a minute, pause, and see if you can simplify this integral. Okay, so to save time, so I simplified, and hopefully you ended up with x to the 4th plus 8x squared plus 12 when you simplify the integrand. And then since it's all addition, you can just integrate those separately by our properties of integrals, evaluate it from 1 to 3, and your final answer, of course, always double check, but your final answer should be 2,126 pi over 15. Okay, so hopefully that made sense. Okay, and our last example is and I'm changing the wording on this a little bit at the end. The region bounded by the graphs y equals e to the x, y equals 1, and x equals 1 is rotated about the x-axis. Find the volume of the solid. Okay, so I drew the graph already, and this is our, in this region here is what we're looking at. And we can see, oh goodness, sorry. My stylus is acting up. Okay, so we can see that we're rotating about the x-axis, so we're going to have our washer method will come into play. And so it's going to look like this. And so our volume will equal, we can look at the other way, pi times the integral from the one that we talked about in class, which was, okay, actually had pi with, I just want you to be able to look at it a different way. So from a to b, in this case, our a to b is from, it looks like from 0 to 1, since we're looking at our x-axis. So from 0 to 1 of pi times r squared of your outer radius minus pi times r squared of the inner. And since we're just talking about x cross sections, that's in terms of x. sometimes some students like to just get that first. Well, if we look at our outer, which is our purple, so it's going to go from the radius is going from the top of the graph to the x-axis. And so that's just going to be e to the x minus 0. So that's just e to the x. And then I don't know if we'll get to it in class. There's other problems where this is not as straightforward. But on your homework and everything, I think you should be okay, because I don't think I put any problems like that on there because I didn't think we would get to it. But and then smaller radius, which is the red circle, is going from 1, right? 1 to 0. So it's just going to be 1. Okay. And then, so if we square those, r squared of the outer, well, that's going to be e to the 2x, right? Because e to the x times e to the x is e to the 2x. And then the r squared of the inner will just be, I was going to do an e, it would just be 1, right? So let's set this up completely. Okay. So that's how it looks if we just substitute back in our values that we did. And again, you could have did it the way we just did example 5. I'm just showing you another way to look at it, because eventually we can pull that pi out and we'll just be left with e to the 2x minus 1 dx, which are two things you know how to integrate. So pause the video and see if you can finish this out. Okay, so you should have, so from this here, after simplifying and integrating, you should have the antiderivative of e to the 2x is just e to the 2x over 2, and the integral of 1 is just x, right? And so evaluating that from 0 to 1, be very careful here, right? Because e to the 0 does not equal 0, so make sure you just don't cancel haphazardly. But your final answer could be either one of those two. So we are actually done with this section. You should be able to do, there are more things to do in this section, but because of time, I just wanted to at least expose this to you, expose the x cross sections. The y are similar. The y cross sections will be similar, except you have to take everything in terms of y, right? And just due to time, we won't have time to go over that. It's also, what if you're rotating about a line? So what if it's not the x-axis? Because that's all we've been focusing on in this section. So there's a little more things that come into play, but this is the gist of it. So if you get an understanding of this, if you see something else that might be a little more elevated in another class, you should be fine. All right, so we are done, ladies.